Okay, correlation does not imply causation. One of the most important statistical things to understand. Just because two things you observed are associated, one goes up, the other seems to go up, doesn't mean that one's causing the other. This happens all the time in headlines, and so this is a major caution. Just because two variables are linked does not mean that they're causing each other. Now, later in the year, we'll talk about why. So when can we say cause? Which short answer is, unless you actually controlled for other variables and did an experiment, you can't say causation. However, if two variables are associated and they're associated in repeated experiments, repeated studies, then we can start to build up. It really does seem that this is causing it. But if there wasn't an experiment, we can always throw in some third variable, in which case, yeah, we can't make as strong a headlines as are often made. So here's an example. The divorce rate in Maine, so how many people get divorced in a year, and how much per capita consumption of margarine in the country. And check out the correlation here. If you graph them with each other, generally speaking, as the divorce rate in Maine went down, so did the amount of butter that people ate. It was a little bit different here, but overall, they seem to be pretty similar. In fact, a 99% correlation is really high, higher than most data we'll look at. But is the fact is when people eat less margarine, they get divorced less often as well? Is margarine causing divorces? I doubt it. Or how about this one? The U.S. spending on science, space, and technology, so NASA and stuff, the more we spend, the more suicides by hanging, strangulation, and suffocation there were in the early 2000s. Almost the same graph it looks like. As one went up, so did the other at the same rates. There were more suicides by hanging, strangulation, and suffocation. At the same time, the U.S. was spending more money on science, space, and technology. So maybe people were just really upset about the extra money we're wasting on stuff like that when there's other problems in the world. I don't know. I don't think that one of these is causing the other. Let's do a more simple example. You might observe that as ice cream sales increase, the rate of drowning deaths also increases. Therefore, ice cream is causing drowning. Well, no, how about, so here's a great simple example of, well, on days when they sell more ice cream, there's also a whole lot more people tend to be at the beach. That's why they sold more ice cream, or it's a warmer day. More people are in the water. You're going to see more drownings, right? You're not going to see very many drownings in the winter, but you're also not going to sell much ice cream at the beach in the winter. And so there's probably something else. Just because these two are correlated, because they are associated, as one goes up, so does the other, doesn't really necessarily mean anything. So again, this is one of the most important basic principles of statistics that the headlines often just ignore. So whenever you see a connection in a headline, hopefully they don't say proves or whatever, but even if they're highlighting the association, don't put too much stock in it. Do your research, figure out what did they actually do in this study. And then I have just a couple of my favorite graphs of just because. So here's a pyramid. Right, there's a pie chart, and you have the sunny side of the pyramid and the shady side of the pyramid. And the rest, most of the pie chart, would say about 70% of it, 75%, is just sky. Or down here you have the part of the pie chart that resembles Pac-Man and the part that does not resemble Pac-Man. So pie charts are fun.